Hi, my name's Lee and welcome to Extra Maths. Today we are going to start looking at your grade 12 financial maths syllabus, and you'll see how closely it ties into your grade 11 work. So let's start first of all by having a look over here and talking about the formulas we know. Now at this moment in time we know that A is equal to P 1 minus IN and A equals P 1 plus IN. And remember, we learned that these were both simple interest, and this one was for depreciation, and this was for appreciation or inflation. Then over here we had our compound interest formulas, and therefore our depreciation we've got A equals P1 minus I to the power n, and for inflation or appreciation P1 plus I to the power n. Now the difference between what we have done in grade 11 and in grade 12 is we are now going to be talking about several investments happening at regular intervals, and for that purpose we distinguish clearly by using a word for it called an annuity. We also talk about loans, and on that basis, we distinguish between two different formulas. The annuity is something like we have when we go and we invest on a savings situation for an insurance policy, where every month we pay in a certain amount of money, and that amount keeps on adding up till at the end of, say, 20 or 30 years, we then get a lump sum payout, and this would be called an annuity. A loan, a nice example of a loan is when we actually go about taking a bond on a house. And that would be a case where we say, right, we need 150,000 bond, and we're going to pay it over 20 or 30 years, and they would work out for us exactly what our installment would be per month to cover the interest that will result as a result of the loan being for so long, and our actual original debt. So let's move on now and look at the formulas involved. The first formula is this one, and this is the one we use for an annuity. So this is when we are saving money, and this one is when we are doing a loan. Now, before I actually get to using these two formulas, I want to go back to our grade 11 work and look at an example where we actually worked with sinking funds. And just point out to you that the sinking fund is in fact a kind of annuity. It's a way of saving to get to the end time, and actually having the money available to actually do this. So let's move on to the example. Farmer Brown purchased a tractor for $441,000. The tractor depreciates at the rate of 20% per annum on a reducing balance. Now remember, last time we mentioned that if it says reducing balance, we are talking about compound interest. The cost of the new tractor increases by 16% compounded annually, because it says per annum. Now it says find the value of the tractor in 6 years' time. Now obviously we've got to see what the replacement value would be on this particular tractor, considering that obviously if we start saving now, the price won't stay the same for the next 6 years. So what we're going to do is we're going to go and work out, if you like, the inflation on this tractor. So it's A equals 441,000, open the brackets, 1 plus I is 0,16. Remember, we talked about this on the revision lesson where we said if we've got 16%, you can key it in like that, but 16% equals 16 over 100, which is the same as saying 0,16. And so we decided it was easier to go there and we could use it like that, although there's nothing wrong with using the percentage instead. Right, and then they want to know for 6 years, so we're going to put the 6 years over there. And let's pull up our calculator. And let's put in the details. So we have 441,000, open the brackets, 1 plus, and they said it was increasing by 16%, so 0.16, close the brackets. And they say in 6 years' time, so we're going to raise it to the power 6, and we're going to get equals. And there we have the value of the new tractor. Now you can see that that amount is considerably bigger than the amounts that we've had up till now. I mean, you can see that's really increased from 441,000 to 1 million odd. So you can see that that is a huge number. So let's put it in. Oh dear, it does help if one goes back to the pen. Let's just bring the calculator up. It's 107,445. So it's 107,445. And let's get the rest of the number off the calculator. 0,78. 0,78. So you can see that's lots of money that's accumulated on this price of the tractor. Now it says if the old tractor is traded in, calculate how much extra Farmer Brown will have to pay to buy a new tractor in 6 years' time. So now we're talking about the depreciation on the present value of the tractor. So we're saying 441,000. 1 minus, now the interest rate that they gave us for our depreciation was a rate of 20% on the reducing balance. That's why I'm using the compound angle formula. So it's 20%, so it's 0,20, and it's for 6 years. Right, so let's see how we look. Let's pull this down a bit so we don't have that problem with the calculator in the way again. And let's bring the calculator up. And what we're going to do now is we're going to go 441,000, open the brackets, 1 minus 0.2, close the brackets, raised to the power 6. And we get the answer there. And you can see that the value of your tractor is considerably less than what it was when you bought it. So that is going to give me 115,605 and 50 cents. So you can see there's quite a big shortfall here between these two values. So in that case, we have to find out what the shortfall will be. So what we would do is we would say, right, the amount needed would equal 107,445.78, and I would subtract how much I could get on my trade-in, which is the book value of this tractor, over here. Right, let's pull up the calculator and actually work this out. So let's clear it. We're going to go 107,445.78, and we're going to subtract from that 11,560.5. Right, and there we see our amount coming out quite clearly as 958845. So 958845. And let's pull up the cents and just check what they said. It's 28 cents. Okay, so now we have that. So now obviously with a business, you've got a problem. If you've got to find that much extra money to buy your new equipment, you must think of a way to make sure that this is not a big problem at the time. So let's read on what the rest of the question asks. It says, Farmer Brown decides to deposit a fixed amount into a sinking fund at the end of each month for the purchase of a new tractor in 6 years' time. The first payment will be made immediately, and the last payment will be made at the end of the 6-year period. Now, amazingly enough, this is very important. The first payment will be made immediately, and the last payment will be made at the end of the 6-year period, because that decides how many amounts of money are going to be deposited over that time period. Assuming that he needs 958,845 Rand 28 cents, and if you have a look there, that is precisely the answer we got over there. So all they're doing is they're helping us out. They're saying to us, here's the answer. So if we got it wrong, we could carry on going and then at a later stage go back and check. It says, calculate the monthly payment if the interest is earned at a rate of 9.2% per annum compounded monthly. Now, what I'd like to do is just stop for a few seconds and show you that this is in fact a kind of sequence, or actually a series, and in fact a geometric series. So let's go and put out a number line and show what's happening. Let's bring it up a little bit. Now what we have is a timeline. And on this timeline, we're starting over here at T0. Now, we have 6 years to save in, so let's just divide this up into each of the 6 years. And they say to me, we are making the first payment immediately. So the first payment is going in over here at X rand. Now, they say that the last payment will be taken at the end of the 6-year period. And they say that he's going to put it in each month. Now, probably in grade 11, you would have only come across them each year or over a bigger period of time, because there would have just been too many for you to work out without the slick little formulas that we are going to do in this section. Anyhow, what they're saying is the end of January, you're going to put another X, the end of February, another X, and so on and so forth, till eventually over here, you put your last X in. Now, what you've got to realize is this interest rate over this whole time is interest compounded monthly of 9.2%. Right, so let's give ourselves a little bit more space to work and let's talk about it. What I'm going to do is I'm going to take the first amount over here. Now, if I take this first X here, do you agree with me that it's going to get calculations all the way through to here and then one more? Because in actual fact, if you think you're starting at the start of January, the start of December would make it a full year. So the fact that you're going to put in a deposit at the end of December means in actual fact that you've gained one lot of interest. So we would take this X and we would go 1 plus 0,092. We would divide it by 12. And what we would do now is we would now say to ourselves, right, well, there's 6 years. 6 12s is 72. And 72 plus 1 means that there are 73 calculations. Just to make sure you're clear on that, let's just stop for 2 seconds. Again, let's suppose I put 10 Rand in on the 1st of January, immediately. Then I'm going to put 10 Rand in on the 1st of Feb. And I'm going to do this all the way through, 10 on 1st of March, 1st of April, 1st of May, 1st of June, 1st of July, 1st of August, 1st of September, 1st of October, 1st of November, 1st of December. Now, if you count that, that is going to be 1 lot of interest, 2 lots of interest, 3 lots of interest, 4 lots of interest, 5 lots of interest, 6, 7, 8, 9, 10, 11, and then the December one would be the 12th one. So in actual fact, our 10 is getting that interest. But now, because I'm putting a 10 in over here on this last calculation, it's actually going to have an extra amount coming in. So actually, if I think about this, I think I'm actually wrong. I think this should have been 72. And then what I'm going to do now is I'm going to take the next amount, which is this X, and I'm going to do the same thing to it. So it's 1 plus 0,092 over 12 to the power 71. And the next one, this X here, is going to be X 1 plus 0,092 divided by 12 to the 70. And I'm going to keep on doing this till I get over here to the very end one, which actually is just X. So where I initially went wrong is I thought there were 73 lots of interest, but there aren't. There's 72 lots of interest, but there are 73 terms. So the N here is going to be 73 because this term does not have interest. So that's, if you like, effectively to the power 0. So 0 to 72 is 73 terms. Right, so now we're going to go along and we're going to remember back to what we were doing earlier on in sequences and series. We learned that a geometric sequence can be calculated by using the formula A, r to the n minus 1 over r minus 1, where r is not equal to 1. Now, if we're treating this as a sequence, it would be a good idea to change it around. So in other words, to start with x, then make your next term x 1 plus 0,092 over 12 to the power 1. And then the next one is x to the 1 plus 0,092 divided by 12 to the power 2. And we would keep on going till we got to the last one. Now, why is it a good idea to actually do that? Well, if we're looking at it this way, our r will be quite a nice number. Whereas if we stuck to the top one, our r would be a horrible little fraction. However, it wouldn't really make a difference. You've got a calculator and you can do it, but it's always better to actually be safe rather than sorry. So if we are treating this as a geometric sequence, let us say that A, the first term, will be x. And our r, remember how we found that? We get that by saying term 2 divided by term 1, or we get it by saying term 3 divided by term 2. Well, if I take term 2 divided by term 1, my r is going to be 1 plus 0,092 divided by 12. Okay, and that's my r value, which in fact is the interest rate that has been increased every year, one more time. Right, so now we're ready to actually use this formula. So we have said it's the sum of 73 terms. Our A is going to be x, and over here we've got r, which would be 1 plus 0,092 over 12 to the power 73 minus 1 over 1 plus 0,092 over 12 minus 1. Now the good news is that one and that one will take themselves out. Now we know the answer of this. They've told us how much money we've got to get. So let's go back and get that. Take it up here. There it is. It's 958,845 and 28 cents. Right, so bringing it down to the work here, we can say 958,845 and 28 cents must equal x times 1 plus 0,092 over 12 to the power 73 minus 1, and that is going to be over 0,092 over 12. Right, so now we're ready to actually use our calculator to work this out, but of course you must realize we are trying to solve for x. So a very good idea before we even pick our calculators up is to reshuffle this equation. Or alternatively, we can work out this answer and put it in. I think for the purposes of this lesson, let's work out the answer of this and then put it in. Let's pull our calculator up, clear it. Now, I like to use the fraction button, so I would hit the fraction button. Then I can see that at the top, I need to open a bracket and go 1 plus, and then again a fraction button, 0.092. And at the bottom, I'm going to divide by 12 because there are 12 calculations per year. Close my bracket, raise to the power 73, and bring myself down to be minus 1. Underneath then, I'm going to use the fraction button again. So you can see this is quite easy, really. You're inputting it exactly as it looks. And at the bottom, a 12. And we're going to hit the equals button. Now you can see the answer you get is 97,35, etc., etc., etc. Now, I'm sure you remember from the last lesson, I did stress that even though we write down part of the number, it is better not to clear your calculator because that little accuracy can make a huge difference when it comes to money, and in fact, when it comes to anything. So all I'm going to do now is I'm going to write down 97.53x. Let me just make sure I wrote that down correctly. Yep, nearly made a mistake there, so good thing I checked. It's 97,35. And that is equal to 958,845,28. Right, so all I would do now, let's just bring ourselves up a little bit. I'd bring my calculator up again. And now I have this in the actual answer. So all I would have to do is key this in and then divide by the answer. So it's 958,845.28, and I divide it by the previous answer equals, and I find that I have 9849.36. 9849.36. And that is what Farmer Brown will have to put in every month for 6 years in order to be able to afford his new tractor when he trades his old one in after 6 years. And you can see that is quite a considerable amount of money, but considering Farmer Brown is a businessman, I'm sure he can manage. Right, so now, why did I actually go this route? I wanted to show you something very interesting. The formula that you are going to use looks like this. It says the future value is x, and on the formula sheet it shows it like this, 1 plus I to the n minus 1 over I. Now, if you have a look at this formula and you look at this formula, I'm sure you can see that there's a great similarity. The x's are obviously the same. This here was 1 plus r, where r actually was the interest rate, how we calculated it. And n is the number of calculations minus 1. And over here, when we went r minus 1, we actually lost that, which in turn made us just have I. So this formula is a direct derivative of that. And obviously, that formula is there for a reason, because it makes your actual calculations much, much easier. So what I'm going to do now is we're going to move on to the next example. And when we get to the next example, I'm going to use the formula on your formula sheet. But however, you're always welcome to refer back to our sum of a geometric series. Right, let's move on to the next question. Right, this one says you take out a loan of 500,000 and the bank charges you an interest rate of 12% per annum compounded monthly. Now, what I want you to do immediately is to look at this and say, loan. Now, as soon as it's loan, we know we're going to be using the formula P equals on your formula sheet, which, if I remember rightly, goes 1 minus 1 plus I to the power minus n over I. Okay? And the bank charges you an interest rate of 12% compounded monthly. You plan to pay off the loan over 10 years in fixed monthly payments to be paid at the end of each month. Now, just for a matter of interest, whenever you have a loan, we normally pay it off at the end of a month. If you go, say, into a shop and you want to buy something and you need a loan for this something, you've got to realize that they're going to ask for a deposit of some sort. So if they ask for this deposit, that would be considered your first payment in effect and would not affect your actual loan, because the loan would be on the rest of the stuff that you are going to pay back. So the original deposit comes off the amount, and then they loan you the rest of the amount which they charge you interest for. So that is why you won't pay immediately. You will always pay at the end of a month. Right, so now it says, calculate the monthly payments you must make if you intend to pay off the loan in exactly 10 years. Give your answer rounded off correctly to the nearest cent. So let's pull up a black pen and let's see what we can do with this. So right, using our formula over here, we know that the present value of the loan is 500,000. Now, a very good idea if you're going to get confused is to look at these words and write down on the side what you have. So you have P, it's 500,000. Then, do we have our I? Yes, we do. They tell me, calculate the monthly repayments, and they tell you the interest rate is 12%. So it's 0.12, and I over 12 would look like that, because we're doing a monthly calculation. And then our N, we're telling it has to be 10 years exactly. And of course, it's monthly, so every year gets 12 calculations. So it's going to be 10 times 12. Right, do we know our X? No, we don't. So that is our unknown. So if we look at our formula, we've got this one, we've got this one, we've got this, and we've got this. So the only unknown is this one, and that's fine. If we've got one unknown in a formula, we can always solve for it. So right, going back to the equation then, it's equal to X. And in our brackets here, we're going to go 1 minus 1 plus I being 0.12 over 12, which, by the way, we could have worked out immediately to 0.01. And that's going to be to the negative. Be very careful about that. If you forget that negative, the whole question goes wrong. Negative 120, and that is all divided by 0.12 divided by 12. Right, now you can see we're faced with a similar situation to Farmer Brown earlier on, in that we would have to work this part out and then divide into the 500 to find our X. Right, so let's pull it up a little bit. In fact, let's leave it down rather, and let's get the calculator up. So let's bring the calculator up, let's clear it. Now we're going to work out this part first of all. So we're going to use our fraction button again, and we're going to say 1 minus, open brackets, 1 plus 0.12, divide by 12, close the brackets. Notice this time I didn't use the fraction button. I could have. There's no problem with that. And I would raise that to the minus 120. And then I would space bar down and to the bottom of the fraction. And over here I've got 0.12 divide by 12. Okay, and if I do that, I press equals, there's my answer for that bracket part. So I know it's 69.7x, and remember what I said to you, we keep the amount, actual amount, in the calculator, even though we're writing down part of it. We want to be sure that when we get to the actual calculation, we are 100% accurate. Right, so pull the calculator up again. We're now going to take our 500,000 and we're going to divide by the previous answer, and we're going to find that our x is 7173.55. So it's 7173.55. Right, so that is how much money I would have to pay back on my loan if I took it 10 years to pay it on. And this is why you find that if you're doing bonds, they're often over 20 years or even 30 years, because you can imagine how high the repayment would be if you're now talking about 500,000 and say over 5 years. It would be even impossible to meet that. Even here, it becomes really very expensive. So that's why they make it over 20 or 30 years to make this more affordable for you. Of course, you end up paying more interest, and I think this question actually addresses that now. Right, let's go up to the next part of the question. Right, the next part of the question says, calculate the interest you will have to pay on the loan. Give your answer rounded off correctly to the nearest cent. Right, so what are we doing? We are paying 7173.55 each month. So how many months are we paying for? We're paying for 120 months. So the total amount would be the payment we're making multiplied by the 120 payments. Right, let's pull the calculator up. So we're going to take that amount and we're going to times by 120. Notice again I used the amount I had in the calculator rather than the rounded off one, and I find I get 860825. And let's just get the cents up, 69 cents. And it says correct it to the nearest cent. Well, that is correct. If you pull it up here again just to check it, you can see that the 0 would not impact the 9. So that makes perfect sense. Okay, so now we have got this amount, and what the question asked me is to calculate the interest you would have paid. Now the interest you pay is the total amount you pay, so the 860825.69, subtract the original loan. So pulling up our calculator, we're going to subtract 500,000, and we're going to find that we are paying 360,825.69 cents. Now you can see that has nearly doubled what you borrowed just by paying it off over 10 years. You've ended up paying more than a half extra onto your amount that you originally loaned. Right, so this could be a very useful section for you one day when you're out there deciding to buy your homes or whatever you might be buying. You can always go and work out for yourself the impact of your payments and how this makes a difference. Right, let's move to the next question. You wish to purchase your first home, a flat. The bank will only allow bond repayments that are no greater than 30% of your net monthly salary. Your gross salary is 8,250 Rand per month, and you have deductions of 25% per month from your salary. Right, so let's talk about gross and net. I'm sure you've heard people talking about that before. Basically, your gross is what you get paid. Your net is after tax and those kind of expenses, UIF, those kind of things. What you actually take home at the end of the day to live on. So when they tell me that I earn a gross of 8,250 Rand, that's good to know, but in actual fact, that's not how much money I have to live on. Now they tell me that I must take off deductions of 25%. So what I need to do is times this by 25 over 100, find out what my answer is, and then subtract it from the gross to find my net. Now there's another way to do this. What you could do is you take 8250 and you say, okay, I want to find out what is left. Now if I'm losing 25%, then I'm actually still keeping 75%. So what I'm saying is 1 minus 0,25. In other words, I'm saying 8250 times 0,75. And that would give you the answer that I would get by doing it this way. I'm going to do it both ways so you can see for yourself which one you prefer. But I often find it's better to go the other route. So let's bring it down a little bit and let's pull the calculator up and see what we're looking at. Right, so what do we have? Let's clear it. It's 8250 and I want to times it by 25% or times by 0.25 and I'm going to get that amount, which I make a decimal, which means the tax and all those kind of things that are not negotiable on a salary, they will come off first, and so I'll be losing 2062 and 50 cents. 2062 and 50 cents. So I take 8250 and I'd subtract that, and that would give me my net salary. So right, pulling up our calculator again, I'm going to take 8250 and I'm going to subtract the answer I got, and I see again I need to use the S to D, changing it to a decimal, and I get 618750. 618750. So that's my net income, doing it that way. Right, let's see how my other way would have worked. Well, okay, now I'd pull up the calculator again, and this time I would clear and I would just go 8250, and now I want to only keep 75%. And if I do that, there you see you get the answer much quicker, and it's quite simple to think like that in actual fact. So it made absolutely no difference to my answer. I still get 6187 and 50 cents. All right, now it says, what is the maximum bond repayment you can afford? Well, they've told you that you can only have a bond repayment of 30% of your net income. So what you're going to do now is you're going to take your 618750 and you're going to work out what 30% is of that. So it's 618750 times 0,3. So let's pull up the calculator again. I've still got it in there. I'm going to times it by 0.3 to get 30%. And if I make it a decimal, I see that my bond repayment would have to be 1,856 Rand 25 cents. So 1856, and let's just check the cents again, 25 cents. So that's the bond repayment. Right, so let's go down and see what else we can do. Now, interestingly enough, this is exactly what the banks do, because we've got the Credit Act, which, as you know, means that we are not in a position to just borrow at will. They have to look at our situation, work out what our net income is, and then offer us an amount of debt based on that, so that way they can control us getting ourselves into trouble and having to liquidate and do all sorts of awful things. So let's go over here to this. This says the bank offers a fixed bond rate of 13.5% per annum, compounded monthly over a 20-year period. So it's compounded monthly, 20-year period. Just while we're here, I want to just mention that in actual fact, a loan, the repayments must be at the same interval. So if you're paying your loan yearly, then your interest rate must be yearly. If you're paying it monthly, your interest rate must be monthly. Right, back to the question. Now, it offers a fixed rate of 13.5% per annum, and we know we can only pay this. If the flat you are interested in buying costs this much money, how much can you afford to buy it? So right, this is a loan, so we're going to go to our formula that looks like this. Okay, fortunately these formulas are on the sheet, and I must say this is one that I actually prefer to check because it's so easy to get it wrong by forgetting that negative sign or making a mistake over there. So definitely I would say this is one you consult your formula sheet for. Now what we're trying to do is we're trying to work out how much loan he could get, or he could get, I think. Right, now it says he pays in 1856.25 because that's all he can afford to pay. 1 plus, sorry, I just now made it plus instead of a minus. 1 minus, open the brackets, 1 plus 0,135, Compounded monthly means divide by 12. And to the power, now they said 20 years calculated monthly. So 20 years calculated monthly means 240 payments. So it's to the 240. Close the brackets, all over I, which is 0,135 over 12. Now the good news with this one is we don't have to do it in bits. This one we can put this right in the calculator immediately and find out how much loan he could have got from the bank. Right, let's pull up the calculator and let's put this value in. So here we have our calculator. Now the good news is we can actually input this exactly as it stands. So let's bring up our fraction button, and we have 1856.25, which is his payment he can make. Open the brackets. We've got 1 minus, open the brackets again, 1 plus, introduce the fraction button again, 0.135 over 12. Bring it over here, close the bracket. I want to raise it to the minus 240. So there's the button to raise, minus 240. And then be very careful to close that bracket there. If you don't close that bracket there, then it'll actually say syntax error. Right, move to the bottom, bring up the next fraction button is 0.135, and we are dividing it by 12. Right, so we're going to hit equals, and there we can see. So we can see that according to our calculations, this person could get a bond for 153,742 Rand and 66 cents. So let's write that down. So it's 153,742, and I'm just going to check that I've written that correctly. 153,742 and 66 cents. Now, what did he want to do? He wanted to buy a place for 150,000. So we can see that he actually can afford to buy this flat. And so it's quite nice. We can work out exactly what it's looking like. And you can see that he's safe. He's even got a bit of extra should he need it, but he doesn't need it. Right, great. That's the end of that question. Let's move on to the next one. Right, now it says a bank is offering a savings account with an interest rate of 10% per annum, compounded monthly. You can afford to save 300 Rand per month. How long will it take you to save up to 20,000 to the nearest month? Now, this is going to raise a section that we haven't done yet, which we will be doing shortly, called logs. As soon as they ask you to work out how long, we are going to be working with things that require us. I'm sure you remember from long ago when you had something like 2 to the x equals 4. You knew how to actually solve that. All you would have done is you would have said 2 to the x is equal to 2 to the 2. And then you would have said, well, the bases are the same, so x equals 2. The problem happens when I've got something like this looking at me, because now nothing I do will make 14 a power of 2. So I've got a problem here, and this is where exponents let me down. And this is where we have to quickly do a little bit on a section called logs. Logarithms will be done in more detail later on, but just for the purposes of this lesson, I want to give you a definition. The definition says the following. It says, if I have log to the base a of b equals c, then a to the c equals b. All right, now you say to yourself, well, sure, that looks a little bit hectic. Let's see if it really is so bad. Well, let's take an example. Now, you've all got a calculator, and I'm sure you've seen this calculator button that looks like this. If you have a calculator that has a button like this is very easy to show you why. Let's suppose I say to you, log to the base 10 of 100. Now, if you input it on your calculator, let's pull it up. Let's clear, and let's get this log button. There it is. So at the bottom here, I'm going to put 10, and over here, I'm going to put 100. You'll see the answer I get is 2. Now, if that's so, do you agree with me that if I take 10, which is what I said I must do, and I raise it to the power 2, the answer is 100. So in actual fact, logs and exponents are directly connected to each other. Now, I quite like this as a way to remember, and of course this works both ways. So if I know this situation, I can bring it down to a log, which means this now becomes possible for me, because I could go log to the base 2 of 14 equals x. Let's pull up the calculator, and all I would do is work that out. So I would go clear, put the button in again, log to the base 2 of 14, and I get my answer, 3,80735, etc., etc. All I'm basically doing here is I'm saying if I take 2 and raise it to that power, so if I went 2 raised to the answer, I would get back to 14. So all this is a way to come up with the exponent when the bases are not the same. So going back to that, let's go back to this and let's use it, just do it again so I can write the answer in for you. Let's pull that up. It's base 2 of 14, and I get that. And of course you can't write down all the displays, so let's go 3,8. And you can see it is possible to solve something where the bases are not the same. Now all we need is this little definition. And perhaps another nice way to look at this definition is to write it like this. Log to a base of a number equals an exponent. And that implies, that's the symbol for implies, the base to the exponent equals the number. So you could learn it like this, or like I've shown you with the top one, or if you're very desperate, you can just use your calculator to help you out. You can work out any time what the log of 100 is, and then work it into exponent form to work out where everything goes on this actual question. Now I'm going to stress this a little bit because we actually do some of our grade 11 work using this log function as well. So this example and the one after are going to involve the log function. So let's go back up again to the actual question and let's clear the screen. I will refer back to that actual definition at a later stage. Let's just take that off as well. Right, back to the question. Right, so it says, a bank is offering a savings account with an interest rate of 10% per annum compounded monthly. You can afford to save 300 Rand per month. So that means every month you are going to put in 300 Rand. That makes this an annuity. So when you have regular deposits going into an account, then it's an annuity. If you have a one-off, like with our timelines on the revision exercise, then it's not an annuity because it'll be doing different things. Like, I don't know if you can remember the question before where we had 10,000 Rand going in, then a year later another 10,000, and 6 months later 15,000. Then no more money going until the end of the period. That is clearly not an annuity because it's not regular installments. Right, so we're going to use the formula F equals X, 1 plus I to the N minus 1 over I. And as I said to you, if you really want to, you're very welcome to use your SN formula from geometric sequences. It is exactly where this has come from. Right, so let's have a look at this now, and it says to me the interest rate is 10%. So I is equal to 0,10, compounded monthly, so it's over 12. Our X is 300 Rand, because that's what we're able to put in each month. And they want to know how long will it take to get a value of 20,000 Rand. So this one we know. So if we go to our drawing here, we know this one, we know this one, we know this and this. What we don't know is our N. Now you can see it's an exponent, and you start to understand why it was necessary for me to talk about logs, because if we're working with exponents, all sorts of interesting things can happen. So let's go over here, and we know that we have 20,000 equals. We know that our X is going to be 300, and we know that our interest rate is going to be 0,10 divided by 12 to the power N. Now the N, interestingly enough, remember, means we will be timesing by 12, because each year we get 12 calculations. So I like to put in the 12N there. They said how long to the nearest month, so in actual fact I didn't need to, but if I do that, I automatically work out to a year. So I think I'm going to do that, and I'll show you at what point you'll read your answer. So this is equal to minus 1, close the bracket, over 0,10 over 12. Right, so now what we're going to do is we're going to unpack this actual equation until we're ready to put it into the calculator. We can work bit by bit, but I think it's quite easy to unpack it. So what we're going to do is we're going to say 20,000. And the first thing I'm going to unpack is this. I can multiply across by that, giving me that. The next thing I'm going to unpack is this, because I can divide by that. And then the last thing I'm going to unpack is this, which I can add on this side, equals, in this case, 1 plus 0,10 over 12 to the 12n. All right, so now this part can go straight into the calculator. So let's bring our calculator up, clear it, bring in our fraction button, and let's put this in. So it's going to be 20,000 times, I'm going to use a fraction button here, 0.1 divide by 12. Okay, space bar down, over 300. Space bar out, plus 1. So you can see it looks exactly like this here. Now, what I do is I press the equals button, and I get 14/9. All right, now you can see we have a problem, because the thing we've got here has got different bases. 14/9 will never equal this or be a power of this. So what we're going to do is we're going to use our logs. Now remember our definition I showed you. I said if we have log to the base a of b equals c, we can say a to the c equals b. So in this case, we're taking it from here back here. So we're going to say log. What would the base be? The base would actually be this thing. So it'll be 1 plus 0,10 over 12 of 14/9, because that would be the actual number value, equals 12n. And now it's a matter of just sticking that in the calculator. So let's pull our calculator up again. It's actually, I can leave it there, the thing for now. The answer is there, so I'm going to go log. At the bottom here, in brackets, I'm going to put exactly what I want, which is 1 plus fraction button, 0.1 divide by 12, space bar out, close the bracket, and then I bring myself up here, and I put the answer in, which was the 14/9, and I press equals. And here I get 53,24. So let's put that down, 53,24 equals 12n. Now that is in months. So at the moment we've got it in months, and that was what the question actually asked. To the nearest month, well, the nearest month would be 53 months. But if I decided to ask you years and months, this is what you would have done. You would have pulled your calculator up again, and you would have taken this answer and divided by 12. And let me just make sure I get that number down. 4,436. 4,436 is equal to n. So that means 4 years. And now if I want to work out the months, I have to work out what portion of a year that is. Now we know that there are 12 months in a year. So all we're going to do is pull the calculator up. We're going to subtract our 4 to get rid of our years. And we're going to times that by 12. If we do that, we can see it's 5 months. If we round off to the nearest thing, so it's 5 months. So just remember, if you ever have to do this, if months, it's fine. You would just give your answer as 53. 53 months. But if you have years, you would divide by the 12, get your year, realize that's full years, realize that's portions of a year, and you times that by 12 to find out how many months of the year would be included. Right, let's move on to the next one. Okay. A person invests 20,000 at 9.5% per annum, interest compounded yearly. After how many years to the nearest year should 55,000 Rand be available? Now, please note, this is not an annuity. Why is that? Well, we can see that there's only one amount being invested, We're not doing a monthly or a yearly or any other regular interval of time investment. It's once off and we're putting it in. The only purpose of this question is to show you how we get the logs asked in the grade 11 work. So what we're going to do is we're going to work with our normal formula. And we're going to say we know that the accumulated amount must be 55,000. The amount invested was 20,000. The interest rate was 0,095, which we divide by 12 because we want monthly. Oh no, I don't. I want yearly, so let's just take that off. And I want to know after how many years should that 55,000 be available. And so really what I'm finding here is that. Again, it's an exponent, and if it's an exponent, then we suspect we're going to have to use our logs. Right, so let's go over here. 55,000 is 20,000, 1 plus 0,095 to the power n. Now, we're going to obviously unpack it, so to get rid of this part, so we're going to do this part first, we're going to say 55,000 divided by 20,000 equals, and we've still got here in the black, 1 plus 0,095 to the power n. Now, this we can do on our calculator. This here is easy enough to just add together. There's no complex workings. And if we pull up the calculator for this part, it's 55 divided by 20,000, and we're going to get 11 over 4. Now, to find that, you can see that that amount there will not be a power of 11 quarters. So what we're going to do is we're going to use the logs, and remember the definition. We know that it's log to the base a of b equals c, means that a to the c equals b. So if you like, we could write it as b equals a to the c and compare it directly to that. And if we do that, we know it's going to become log. The base of the log, by the way, always tucks underneath the tail of the log, the g, so that we don't get mixed up. The number we're working with is 11 quarters, and the answer we're going to get is n, so the answer of a log is an exponent. Right, so now we're going to pull up our calculator, and we're going to take this key, and we're going to put in the base of 1.095, and we're going to space bar here, and we're going to put the answer in, and we're going to press equals. And so we find that it's 11,146, actually 11,147. But the question said to me, after how many years to the nearest year? Now, if that's representing years, the nearest year would be 11 years. Because comma 1 won't get you onto the next year. Definitely not. It would have to be above 5. So it would be 11,5 and above. That would make it 12 years. So we know it's going to take us 11 years to save that amount of money on that particular interest rate. Right, so I think we've revised enough on the grade 11 work and use of logs, which is grade 12 work. Let's go on to another question. Right, it says here, how much money can be borrowed from a bank if the borrower repays the loan by means of 30 equal payments of 1,250 Rand starting in 1 month's time, if the interest rate is 14% compounded monthly? You remember earlier on I mentioned to you that if you are paying a loan or whatever, you should have your interest rate working the same as the amount of installments that you're putting in. So if you're paying 30 installment things, and it must be done per month, starting in 1 month's time, and then this must be compounded monthly. What you would have to do is you'd have to adjust your interest rate. Now I'll show you at the end of this question how you would do that, should there be a problem. And then you can see how to work on from this. So how much money can be borrowed? So right, we want to find our borrowing amount, which is our P. If he pays off using 30 payments, and each payment is 1,250 Rand, starting in 1 month's time. Remember, we've talked about starting in 1 month's time. We never pay immediately. We take the loan, and at the end of that month, we would pay our first installment. If the interest rate is 14%, compounded monthly. So that's what we've got. And we have to now go and work out how much money can be borrowed. So we want that amount. So P is equal to X, open my brackets, 1 minus 1 plus I to the minus N all over I. Right, P is what we're looking for, so we leave it alone. Our X is 1250, and we have 1 minus, and what we're going to do here is we're going to go 1 plus 0.14 over 12 to the negative 30, because they've told me how many installments I'm going to make. So I don't even have to think in this one. It's not like I'm saying so many years and 12 times a year. They've already decided for me exactly how it's going to work. And that's over 0.14 over 12. Right, so this is going to be relatively straightforward for us to work with. Let's pull the calculator up. And it's decided to block my work, so it's not too problematic. Let's just work with it like this. So let's clear it. 1250, wait, clear. Let's use the fraction button so we input as we look. 1250, open the brackets, 1 minus open brackets, 1 plus, fraction button, 0.14, divide by 12, spacebar out, close the brackets, raise to the power, negative 30. Remember that negative. And remember to use spacebar out and you close the brackets. If you don't do that, it will say an error. Right at the bottom, we're going to put the fraction button in again. And we're going to go 0.14, divide by 12. Right, we're going to press equals, and there we have it. So we know he can have a loan of 31,487. And let's get the cents, 44 cents. Okay, so that was relatively straightforward. Just for a few minutes, I want to stop and just quickly talk about what happens if, for some reason, we are working with this and we need to change the rate. So let's say, for example, we have got a quoted rate of compounded quarterly of 16%. But I want to invest monthly. So what I'm going to do is I'm going to use a similar formula to what we used when we were doing I effective. The I effective looked like this. It's 1 plus I nominal to the N. So all we're going to do is we're going to adjust this formula to look like this. We're going to say 1 plus I over M to the M equals 1 plus I over N to the N. Because what we're doing here is we're converting from a quarterly to a monthly interest rate. So I would say 1 plus 0.16 divided by 4 to the power 4 must equal 1 plus I, which is what I'm looking for, divided by 12 to the power 12. Now it would just be a matter of manipulating this. Over here I would get 1 plus 0.04 to the power 4. And what I could do to get rid of this now is I could take the 12th root of this side, as long as I take the 12th root of this side. So that's going to be 4 over 12. Right, so this then gives me 1.04 to the 1/3 equals 1 plus I over 12, which means I have 1.04 to the 1/3 minus 1, and I'm going to have to times by 12 to get my I. All right, so what did I do? I took the 1 over, and then I said to get rid of this, I times by 12. Let's pull the calculator up. Let's clear it. And let's go 12 open brackets. Open brackets again, 1.04. Close brackets, raised to the power. And I'm going to put it to a fractional power. That's not a problem. Space bar out. And then I want to minus 1, and I want to close the bracket. And there's my answer. So I find that I is 15.79. Okay, so that would be the interest rate we would work with on our monthly calculations. Right, let's go to the next question. Bob, Sandy's fiance, applies for a bond of 650,000 Rand in order to purchase a townhouse. The bank charges an interest of 11.5% per annum compounded monthly. What will his monthly repayment be if he pays the bond off in equal monthly installments over a period of 15 years? Right, so let's have a look at this and see how we're going to do it. He's taking a bond, which is in effect a loan. So we are going to work with this formula. And what do we know? Well, they tell me that the interest is charged at 11.5% compounded monthly, so I is known. We know that he's going to pay it off in 15 years, so we know our N. And what we don't know is how much he's going to pay, but we do know the loan value would be 650,000 over here. Right, so once we've established what we know and we are in a position to actually work with this, let's go and see what happens. So 650,000 is how much money he wants to borrow. We are trying to find out what he has to pay every month if he does that. So it's 1 minus 1 plus. Now let's check it again. The interest rate is 11.5 compounded monthly, and they want to know if he's paying off in equal monthly installments. So we're working monthly, all's well. So we can go along here and we can say 0.115 divide by 12 to the negative. Now he's doing 15 years. So 15 times 12 is what will go up here. Close your brackets. All over I, which is 0.115 over 12. Right, so once we're here, we're ready to start working with the calculator. I think let's leave it down here, bring the calculator up. We are obviously going to calculate this thing. And when we've got it, we're going to divide it in there to find out what Bob is going to be paying. So let's go over here and dig up the calculator. Let's clear it. And we're using our fraction button. Now, what I'm going to do with this particular example, after I've done it this way, I'll show you that if we unpack it, we get exactly the same answer. Right, so if we look over here, we have this situation looking at us, so let's input it. We want to work out this whole bracket thing, so it's 1 minus, open the brackets, 1 plus fraction button, 0.115 over 12. Bring it over here, close the brackets, raise to the power negative, and I've been very lazy, I haven't even worked out what this is, so I'm going to input it as it stands. Space bar down to the bottom of the fraction, bring it in, and I've got 0.115 divided by 12, and I can press equals now, and that tells me what is in this whole bracket's worth. So the whole bracket is x equals 85.6, not equals, sorry, x is x times 85. Let's just make sure I didn't make a mistake there. 0.6, yes. And that's equal to 650,000. Right, so now we're in a position where we have to find the x amount. So what I'm going to do now is I'm going to divide the 650,000 by the 85.6. So that's what I'm doing, 650,000 divide by 85.6. Let's pull up the calculator. We've already got that in there. So all we have to do is go 650,000 divide by the answer equals. And I find that I have to pay 7593 23 cents. Now you can see that that is quite a lot of money, but then he has taken quite a sizable loan. His loan is a bit on the big side in the sense that 650,000 over 15 years. You know what would be interesting? Let's have a look how this would have changed if his loan was over 30 years. Let's see actually what it would look like. So let's go back to the same question, same amounts, but this time I'm going to take 650,000 and I want to work out what his repayment would be if I paid it over 30 years. So all of this will be exactly the same. And this would be 30 times 12, so it'll be negative 360. So it's 30 times 12. and that would be over 0,115 over 12. Right, let's bring up our calculator and let's input what we've got here. So using our fraction button, we can say 1 minus, open brackets, 1 plus, bring our fraction in, 0.115, divided by 12, close the bracket, raise to the power negative 360, bring it down to the bottom, put in another fraction, 0.115, divided by 12, and we're going to hit equals. Okay, so what we're going to get is 100.98. I think this will be quite interesting for you. You will start to see how important it is to always pay as much as you can when you have debt. Right, so now once I'm here, I would pull out my calculator again. Let's just get it down to the bottom a little bit so we can write. Sorry, that doesn't look very clear, so let's just tidy that up a bit. This is going to be 100. Right, on the calculator we pull up the value. We've got 100.98 in the calculator. So we're going to take 650,123, divide by the answer equals, and we find that he's only paying 6436, and I think 98, but I'll just check that again. No, it's 89. Okay, 89. So now if you look at this amount versus this amount, there is a 1,100 difference, but let's now see what the impact to the actual calculations would be by doing that. So let's go down here and let's see what they ended up paying for their loan. In case 1, Bob took 7,593 Rand 23, and he paid for 15 years, 12 times a year. In case 2, he paid 6,436 Rand 89 cents, and he paid for 30 years, 12 times a year. So let's see what the difference would be for him earning on the one, how much interest it costs him on the one versus interest on the other, and then see if we think it's worthwhile actually taking longer to pay debt. Let's pull up the calculator. So I've got this one up here already, so I'm going to use it. Times 30. Times 12, and you can see that's how much he ends up with. So it's 231728. Put it up again. 1.95. All right, and let's see what happens on this one. So he's got 7,593 Rand and 23 cents times by 15 times by 12. And he gets 13667, 13367. Bring up the calculator again. 8140. Do you see how much better off he is there versus there? If you look at that, you can see clearly that by paying that extra 1,100 Rand, he cut his debt down for 15 years. He was less time paying it. Plus the fact that in terms of interest that it cost him to loan that money, there was a great improvement. Let me show you what I mean by that. So what am I saying? I'm saying, look, his original loan was 650,000. So in other words, in interest, he ended paying, and I'm going to be good and not use the calculator, and that's going to give me 8. 12, it's 6. That's how much interest he ended up paying. On this case, he still had the same loan, and here he ended up paying a lot more interest. It'll be 6, and that's 12, it's 6, 1. And you can see that that is a sizable difference in interest rate. So although it's more affordable for him at this amount, it costs him a lot more over the period of time that we're working on. So just remember that, and in fact, it's a very good exercise if you know anybody who has a bond on their houses. Just by increasing their bond by 50 Rand a month, they can make a huge difference to how long they have to pay their debt. Because what happens is that 50 Rand comes straight off the capital and doesn't actually get any more interest put on it. So with the result, you end up scoring. I think one time I actually tried this, and when I tried it, I think I saved myself about 4 years on the loan by paying 50 Rand extra. So really, it's well worth looking into. And of course, you are now in a position that you're able to actually do this. Right, let's now go back to one of the examples we had earlier, and let's see that if we made a slightly bigger payment, how much time it would have saved me on the loan. Remember the one we took out? We were paying 1,250 Rand for 30 months at 14% compounded monthly. And we had found that that is how much the loan was worth. Now, what I want to do is have a look. What would happen if I paid 50 Rand more per month? How would this change how long it took me to pay it off? So let's take 31,487 Rand 44. 44 as my P. And now my X is going to change to 1,300 Rand. And here I have 1 minus 1 plus 0,14 divided by 12. And this will be to the negative n. And in fact, it would be negative 12n because we're calculating monthly. And that's all over 0,14 over 12. Right, so now what I'm going to do is I'm going to work out what that n has to be. To do that, I'm going to unpack this a bit so that I get it in a nicer form. So I've got 31,487.44 times by 0,14 over 12. That gets rid of this. Divide by 1,300. And I've now got it equal to 1 minus 1 plus 0,14 over 12 to the negative 12n. Right, so now we can work this out and put that answer in there, or we can still carry on, and I think I'm going to still carry on. So I'm going to bring this over, because you see the whole bracket is negative, so it makes sense to bring it this side. And I'm going to make this 1 minus 31,487.44 times 0,14 over 12 divided by 1,300. Right, let's pull the calculator up and let's clear it and let's put in this value. So we've got 1 minus fraction button. Over here I've got 31,487.44 and I'm going to times that by 0.14 divided by 12. Bringing myself to the bottom here, divide by 1,300 gives me the answer that. So it's 0,717, and I've still got this over here. Now, of course, you can see that this is a case of us using logs. So we're going to say log to the base 1 plus 0,14 over 12 of 0,717 equals minus 12n. Right, so let's stick this in the calculator and see what we get. We've still got that value in there, so that's rather nice. So we're going to go log. At the bottom here, we're going to open brackets, 1 plus, put a fraction in, 0.14 divided by 12, close the bracket, and then going up here, we can put our answer in and we press equals. Now you see you're going to get minus 28.63. Now, if you remember rightly, this example up here said it took 30 months. Look at the difference now. This is months still. I haven't converted to years. So in months, it would now only take me 28.63 months, or if you like, 29 months. So that little bit of money has saved me a whole installment in actual fact. And so all the interest that goes with it, in fact, is even more than one installment because it's 28.63. So obviously, the more money we put in, if we put, say, 100 Rand extra in, it would decrease the amount of time considerably as well. Right, so I think you've realized now that it's actually quite nice knowing these formulas and that you're in a much more powerful position now to actually work out the effect of debt or the effect of saving in your life. And let it rather be the effect of saving than the effect of debt. Anyhow, thank you for joining us today, and we look forward to seeing you next time.